number 4 on the lecture examples. And there's 6 parts to this. Question A wants to know which way will the equilibrium shift if carbon monoxide is added? So we are increasing the concentration of carbon monoxide. Well, if we increase the concentration of carbon monoxide, then that would cause, so if you think about a Q expression, right? So increasing the concentration of a reactant would then cause Q to get smaller. And so to readjust to get Q back up to KEQ, you would have to make more products. So this is going to have to shift towards the products in order to use up that additional carbon monoxide. If you just think about it, like these are breaking down to make these and these are combining to form that, then if you add more carbon monoxide, then you're going to have more of the forward reaction, less of the reverse reaction. So, I mean, mathematically, conceptually, it makes sense that adding carbon monoxide is going to shift to the products. Or some teachers would say to the right. Question B. Question B wants to know which way will the equilibrium shift if pressure is increased? So increasing pressure shifts the equilibrium to the side with the fewest or fewer moles of gas. And this is a tough idea. There's actually a whole nother mathematical approach to pressure changes, but conceptually, if you increase the pressure, right, that's going to decrease the volume of the system. It makes everything much more packed in, and so to try and alleviate that crampedness, the equilibrium tries to shift towards the side that would take up less space. Since gaseous substances are the most volume comprehensive, then it's going to shift towards the side that takes up the least amount of space. That would be the side with the fewest number of moles of a gas. Increasing pressure shifts it to the side with the fewer moles of gas. So then I need to look. All of these reactants and products are gaseous substances. That means on the reactant side, we have 2 moles, 1 mole, that's 3 moles of gas on the reactant side, and you have 1 mole of gas on the product side. So increasing the pressure is going to shift it to the products. Or to the right. Question C wants to know, which way will the equilibrium shift if temperature is decreased? So temperature changes. If you have a thermochemical equation like this one, if you are removing, or if you are lowering the temperature, effectively what you're doing is you are removing the energy from the system. So if you're lowering the temperature, that amounts to us removing those kilojoules of energy. And when you remove something, the equilibrium shifts to try to replace that substance or that quantity, that thing. This time it's energy, it's not a substance. So it's going to shift to try and replace what's removed. So by lowering the temperature, we are going to shift it again to the products. Who wrote these? Does every one of them shift to the products? For D, how will the concentration of hydrogen change if CH3OH is removed from the system? So when we talked about C, we talked about removing things shifts the equilibrium towards it to try to replace it. So if I remove CH3OH from the system, more of these reactants are going to combine to try to reproduce the removed CH3OH. That means that the concentration of carbon monoxide and the concentration of hydrogen are going to decrease from what they were because I'm going to remove the CH3OH. That's going to shift the equilibrium towards the products, increasing the concentration of the products and decreasing the concentration of the reactants. So it's going to shift to the right. which is bad news for hydrogen because it's on the left. So that means the concentration of hydrogen is going to decrease. E asks us, how will the concentration of carbon monoxide change if temperature is decreased? So earlier we had a temperature, right? We said temperature is decreased, it's going to shift it to the products. So if we're shifting to the products, that means that carbon monoxide is a reactant, it's shifting away from it. So that is going to cause the concentration of carbon monoxide to decrease. And lastly, we have question F. How will the concentration of hydrogen change if pressure is decreased? So if we decrease pressure, now that they can take up as much room as they want, it'll shift towards the side with more moles of gas because they can expand out. They can take up as much space as they wish. And so it's going to shift towards this side, which has 3 moles of gas as opposed to 1 mole of gas. Since hydrogen is on the side with more moles of gas, it will benefit from this expansion. And so that means the concentration of hydrogen gas is going to increase.